পরমাণুর অন্দরমহলে রয়েছে অতি ক্ষুদ্র প্রোটন কণা। সেই প্রোটন কণার মধ্যেও যে লুকিয়ে আছে আরও ৩টি ক্ষুদে কণা, যাদের নাম হল কোয়ার্ক, তার ইঙ্গিত বিজ্ঞানীরা পেয়েছিলেন ২০ শতাব্দীর ৬-এর দশকেই। অথচ এই কোয়ার্ক কণাদের আলাদা করে কখনো দেখা যায় না কেন? এই ধাঁধার সমাধান করে ২০০৪ সালে নোবেল পুরস্কার পেয়েছিলেন যে ৩ বিজ্ঞানী, অধ্যাপক ডেভিড জনাথন গ্রস তাঁদের মধ্যে অন্যতম।
Big advances in science have historically mostly been contributed by young people, for the obvious reason that the young people want to do something new, and they're more willing to take risks. They're not as burdened by old ideas. Young people are less reluctant to question biases or traditionally held beliefs of their elders, right. Sometimes in a silly way, but often in a very interesting way, and come up with new ideas that contradict those old. And they're full of energy and creativity often. So it's just, every scientific field takes very seriously the education and the promotion of young people, because that's the future of science. The important qualities of a successful research scientist is the ability to do research. And what that requires are a bunch of things. Curiosity, the ability to ask good questions, and then all sorts of techniques which are really hard to describe because they're often vague, and and we don't really know how to teach that. How do you teach creativity? So the way we teach graduate students, by and large, is best described as mentoring as opposed to teaching. It's sort of like an apprentice, The one thing that's good about teaching is not just the effect it has on students, but the effect it has on teachers. It's often said that the best way to learn something is to teach it. So even in subjects that you work in, that you know very well, that you use all the time, when you have to teach it, you often realize, well, I guess I didn't really understand it that deeply. So it's very rewarding, right, for the teacher as well as the student. So, and society, most countries, does not respect and reward teachers as much as it should.
Right.
We think it's a trivial thing to teach. It isn't. It's an art, and good teachers are hard to find. The scientific method itself is based on 3 components, really. Observation. You observe the universe, you observe particles, you observe protons, sometimes with very delicate instruments now are required. And then you actually carry out controlled experiments where you vary the observations, you set up initial conditions, you throw things together, measure what comes out, and then you change the setup and see how the results change. Precise measurements, so observation and experiment. But then the goal is to understand. So the final goal is to produce an explanation or a theory, a model or a theory that
hypothesis, you might say.
Well, it might usually, the goal is a theory.
Goal is a theory.
The way to a theory is to is to come up, and that's what you can't really teach. Come up with new ideas, new models, new mathematical expressions, especially in physics, where we really have to contend with the fact that the laws of nature are written, as Galileo said beautifully in the language of mathematics. Come up with mathematical descriptions based on some ideas, symmetries, whatever, and then make predictions. if we think we understand what's going on and can formulate in a quantitatively precise fashion what our speculations are, then we can use them to extrapolate our ideas to new realms which have not yet been observed or measured and make predictions. And the value of making predictions and testing them is that in the end, we can confront these predictions with the results of new measurements that are carried out. And if they don't work, then we're clearly in the wrong direction. So nature is much smarter than us, and besides, nature is nature. So
that's
we're
right.
trying to understand nature. So a final word is given by a very harsh judgment of nature.
Right.
Why is it harsh? Well, nature never says, yes, you're correct. It only says, so far you're not wrong.
Mm-hmm.
So far you're not wrong. But next test, you could be wrong.
Right.
And that often happens.
Mm.
So if you start trying to explain a certain set of phenomena, you might come up with a model which is sometimes beautiful and wrong, sometimes very complicated and wrong. Might explain a little more, but eventually fails to explain the data, and then you know you're wrong. Nature never says yes.
That's
Never.
right.
And in fact, we physicists tend to believe, history has proven, that most of our successful theories are essentially, at their core wrong. Not in the sense that they're not useful. Quite the opposite. They're usually part of a greater, more comprehensive theoretical scheme in which they're a well-defined approximation.
Yeah.
So, for example, Newton's law of gravity and Newton's classical mechanics is wrong. It does not agree with all experiments. It doesn't agree when particles move very fast. You need relativistic mechanics.
Right.
It's not correct if you consider, say, the behavior of electrons and nuclei in atoms. You need quantum mechanics, a quantum version of classical mechanics. Not to say that Newton's is really wrong, it's just the limit. It's the approximation to quantum mechanics for big bodies like the moon going around the Earth. So if you want to send a rocket to the moon, you don't have to use quantum mechanics or relativistic mechanics. You can just use Newton's law. That's a good enough approximation. But at the core, it's wrong. So is classical mechanics in general. You need quantum mechanics.
Yeah.
So that's how things progress in science usually. And eventually, we suspect, until now, all of our theories are limited in that way. We're always challenging, trying to find, looking at experimental and observational results to find clues as to where our current ideas might break down and challenging them. And if nature is kind, it often points the way to where we have gone wrong or made assumptions that are just approximately correct, but not in the end correct.
That's a very deep answer.
Thank you, David, for this fantastic interview and sharing your profound wisdom with Bigyan Patrika.
বিশ্বের বিভিন্ন প্রান্তে ছড়িয়ে থাকা বাঙালি বিজ্ঞানী ও বিজ্ঞান প্রেমী দ্বারা পরিচালিত মাতৃভাষায় বিজ্ঞান প্রসারের একটি অব্যবসায়িক প্রয়াস bigyan.org.in বিজ্ঞান যারা ভালোবাসে বা ভয় পায় তাদের জন্য। এই পর্বটি ভালো লেগে থাকলে লাইক ও শেয়ার করে সবার সঙ্গে ভাগ করে নিন আর আমাদের চ্যানেলটি সাবস্ক্রাইব করে আমাদের সঙ্গে থাকুন। কমেন্ট করে জানান আপনাদের মূল্যবান মতামত। পরের ভিডিও প্রকাশের নোটিফিকেশন পেতে হলে বেল আইকনটি প্রেস করতে ভুলবেন না। আমাদের পাশে থাকার জন্য ধন্যবাদ।